the lecture series of Basic of Database Management System, today we discussed about the relational model. What is relational model? That is a collection of tables, that a database is in the form of the tables. Each table have a unique name. We have to find the relationship between different tables with the help of this relational model. So we discussed what is relational model and how we find the relation between different tables. So relational model represent the database as a collection of relations. A relation is nothing but a table of values. Every row in the table represent a collection of related data values. Relational model is a collection of relation in which relation represent a table, and we have to find the relation between different tables that related to a database. A database is a interrelated collection of data, and this data is represented into the form of tables. These rows in the tables denote a real-world entity or a relationship. For example, we have a table, this student. This is the student is the name of the table, student is the name of the relation, and we have different attributes, that is ID number, name, phone number, and date of birth are called the attributes. On the basis of these attributes, we have identified this entity student, and these are the values in this relation student. So we have to find the relation between different tables on the basis of, with the help of relational model. So we have three tables: student, take course, and courses. And on the basis of these different tables, we have find the relation that which student have read particular, teach particular subject, which student take which course. We have find these type of relations with the help of this relational model. So before finding the relation between different tables, or we have for understanding the different relation models, we have to understand certain terms that are related with this relational model. First is the attribute. Each column in a table represent an attribute. Attributes are the properties which define a relation or which define a table. For example, in the previous example, this ID number, this name, phone, and date of birth are called attributes. And in this example, this ID number, class ID, semester, this also represent the attributes that define the properties of this relation, take course. This attributes define the properties of this student, and in this table, these class ID, title, and classroom are defined the properties of these courses. So on the basis of these attributes, we identify one entity from the other entity, or we can say that we distinguish one entity from the other entity on the basis of the attributes that given to us. Second terms is tables. In a relational model, the relations are saved in the form of the tables in a table format. It is stored along with its entity, that's the name of the entities. A table has two properties, that rows and columns. Rows represent the records and column represent the attributes. Each table have a unique name that define the name of the relation, and in each table we have certain columns and rows. That rows are representing the records, the values, and the column represent the attributes. Then we have a tuple. Tuple also represent the rows. It is nothing but the single row of a table which contains some single record. Then we have defined the relational schema. A relational schema represents the name of the relation with its attributes. If we talk about the relational schema, the name of this table, that is student, and this table is represented as a relation schema. Then the degree. The total number of attributes in a table define the degree of a relation. For example, in the student table, we have 4 attributes, so the degree of this table is 4. Then we have cardinality. The total number of rows present in the table represent the cardinality. So this represents the degree. The total number of column represent the degree, and this actually represent the cardinality, that number of rows. Then columns simply represent the attributes. On the basis of attributes, we have distinguished one entity from the other entity. Then relation instance. The relational instance is a finite set of tuples in the relational database system. Relational schema never have duplicate tuples. The relation instance means at a particular moment of time, what are the values stored in a table is called the relational schema. Then we have relational key. We have identify any entity. We have identify any entity on the basis of certain key, that called primary key, super key, and the candidate key. So every row has one, two, or multiple attributes, which is called a relation key. On the basis of this key, we have uniquely identified the database. Then we have attribute domain. Every attribute have a domain. So every attribute have some predefined values and scope, which is known as attribute domain. For example, we have use here name. So in name, we can use only the characters. We have not represent the name in the terms of numbers. So for domain, we have identify, we have decided the domain for name is character or string. So we have used only character and string for name. We have not using the number integer for name. So we have a specific domain for every attribute in the table. So these are some terms that are related with the relational model. This is the structure of any relational database. This is the name of the relation, that is student. This database is related to the student. So the student is the name of the relation. These are the attributes, that student number, last name, first name, initial name, date of birth, and the GPA. These are the attributes, or we can say these are the properties that identify this student from the other student. And this student number will consider as a key. This is student number we have considered as a key, because for every student we have unique student number that distinguish one student from the other student on the basis of the student number. These are the tuples. Every row represent as a tuple. So tuple is a collection of rows, or we can say that tuple is simply a set of record for a particular student. Degree is the number of attributes that available in a relation is called the degree of the table. So the degree of this table is 6, because we have 6 attributes in this table. Then the cardinality, the number of rows in a table is called the cardinality. So these 1, 2, 3, 4, 5, 6, this is the cardinality of this table. And this whole is called the relation, that combination of the attributes, and for attributes we have particular set of values is called the relation. So this is the structure, this is the data structure for defining any relation, or this is the format how we store the data into the relational data model. This is the format for the same, in which we have represent the data into the form of rows and columns. While creating any database, we have imposed certain integrity constraint over a relation. We have imposed certain constraints over a relation. So every time we have inserting the data, or every time we have updating the data, these constraints, first check these constraints, then we have update or insert any data. Before any updation or before any insertion of new data, first we check for the constraints, then only we have, if the constraints have passed the query, then we have only changed the data. So what are this integrity constraint that we have applied on any relation? Integrity constraint we have used to ensure the accuracy and the consistency of data in the relational database. Integrity constraint we use for ensure the accuracy and the consistency of the data into the relational databases. Integrity constraints are set of rules that the database is not permitted to violate. For example, if we can say that no amount will be debit from any account number if the amount of that account is less than 1000. If the amount of any account is less than 1000, then the person is not able to debit any amount from that account. So before any transaction, before any debit transaction, first we check the amount of the account. This is the integrity constraint. Constraint may apply to each attribute, or they may also apply to any relationship between tables. Integrity constraint ensure that the changes that any updation, deletion, or insertion made to the database by only authorized user do not result in a loss of data consistency. That integrity constraint can be applied only by the authorized user, because if unauthorized user can and make any updation, deletion, or insertion, then there is a chance of loss of data consistency. So integrity constraint guard against the accidental damages to the database. So that's why we have imposed certain constraints on any relation. That constraint will be checked when we have make any updation, deletion, and insertion to guard against the accidental changes to any databases. So these are the different types of integrity constraint that we can apply on any relation. So these are domain constraint, entity integrity constraint, referential integrity constraint, and the key constraint. We will discuss these one by one. First, we will discuss about the domain constraint. As the name implies domain, that we have decided the domain of a particular attribute. So in domain constraint defines the domain or the valid set of values for an attribute. We can say that in a table we have different set of attributes. Like in this table we have attributes like student ID, name, and semester and an age. We have defined the domain for every attribute. That domain contains the set of values only related to that attribute that we have applied. So the data types for domain include string, character, integer, time, date, currency, and etc. For student number, if we have decided the domain of student number is integer type, so we can only insert the data of the integer type into the student ID. If I add a new row here as A, then this will not be inserted because the domain of the student ID is integer. We are not able to add with character into the student ID. For example, we have defined the domain for age is integer type, and we are trying to adding the age as A. So this not allowed here because A is an integer value. If we have talking about the SQL, we have used the data type like char, varchar, varchar2, time, int, time, date, for defining the domain of attributes in a table. So the domain constraint defines the domain or the valid set of values for an attribute, and that attribute will have only the values that the constraint we have defined on that particular attribute. So we will not insert the values in integer. We are not able to insert the values of characters, and in character we are not able to insert the value of the integer. Whenever if we have defined the integer domain for this student num ID, we are not able to insert the values that related to the character here. So whenever we have inserting any new values or we have updating any new values, we will always check for this domain constraint. Then we have entity integrity constraint. As name implies, entity integrity constraint states that primary key values cannot be null. Because we know that if any key we have decided as a primary key, and primary key can never be take the null values, because primary key uniquely identify our database. If the value of if any value in the primary key attribute is null, then how we uniquely identified the database? So the entity integrity constraint always check that the primary key value cannot be null, because the primary key value is used to identify individual row in a relation, and if the primary key has a null value, that we cannot identify those rows. So it is necessary that when we have insert any new row into the database, then we check for the primary key value cannot be null, because primary key can never be null because that uniquely identify our database. So a table can contain a null value other than the primary key field. I can say that this is the table of employee in which we have three attributes, that is employee ID, employee name, and salary. So if we consider this attribute as a key, that as a primary key, then this is not allowed, because in this we have null value. There is no value for this employee ID for the employee name Logan. So this is not allowed, because if this employee ID is considered as a primary key, then the null value is not allowed for the employee ID. Maybe this is null, but we need to store the value as the primary attribute or the primary key as employee ID. So when we have insert any new row into the database, then we have checked for the primary key cannot be null, and this will be checked by the entity integrity constraint. Then we have checked for the third constraint, that is referential integrity constraint. We have know the concept of the primary key and the foreign key, that primary key that uniquely identify our database. And for finding the relation between two tables, we have using the concept of the foreign key. If the primary key of one table becomes the foreign key of the second table, then we have used the concept of the referential integrity constraint there. What is this referential integrity constraint? This always be defined between two tables, because I earlier say that we use this referential integrity, or we use the concept of the foreign key to find the relation between two tables. So this referential integrity constraint is always be specified between two tables. This referential integrity constraint is enforced when a foreign key references the primary key of a table. I see is that the primary key of one table become the foreign key of second table. In the referential integrity constraint, if foreign key in table 1 refers to the primary key of table 2, then either every value of foreign key in table 1 must be available in primary key value of table 2, or it must be null. We can say that if we use the primary key of one table in any other table, that is table 1, then we can say that the table 1 contain only the values that in the primary key. If in the primary key we have two values, that is 1, 2, 3, 4. If we consider that employee ID as a primary key, and if it contains this 1, 2, 3, 4 in table 2, we can say that this is our base table, and we will use this in a table 1. Here we have department ID, department name, and this employee ID we have used as a foreign key. Then it will contain only values 1, 2, 3, 4, not more than 1, 2, 3, 4, not different from 1, 2, 3, 4. Okay, it will contain only either 1, 2, 3, 4. It will not contain, 5 is not allowed here. Maybe it will contain null value, but it will not contain the value that not contained in the primary key of the base table. So when we have applying any foreign key, then we see this rule that foreign key cannot be contain the value that will not contained by the primary key of the base table. So the rules for creating this referential integrity constraint, that you cannot delete a record from the primary table if matching record exists in the related table. If we have using the primary key as a foreign key, then we will not delete any record from the primary key table from the base table if that data is used in the foreign key. You cannot change a primary key value in the primary table if that record has related record. If we have used this employee ID as a primary key, and we have used this employee ID into the another table as a foreign key, then we have not changed any primary key value in the base table. You cannot insert a value into the foreign key field of the related table that does not exist into the primary key of the primary table. As I say that we cannot use here as 5 because 5 is not present into the base table. So we cannot insert any value that will not, we cannot insert any value into the foreign key that will not contain by the primary key. So we can enter any null value into the foreign key. It is possible that we have accessed the value of the primary key into the foreign key, but it may be also that foreign key contain the null value. Primary key can never be contain the null value, but it is possible for the foreign key that it will contain the null values, specifying that the records are unrelated. So for foreign key, only we have contained that value that present into the primary key of the base table. We can also have the null values. We cannot make the changes in the primary key data in the primary key of the base table if we will contain that record into the foreign key. So whenever we have applied the referential integrity constraint, we have to be checked for these rules that we cannot delete any value from the primary key base table if we use that record into the foreign key table. So this referential integrity constraint we use when we have to find the relation between these from any two tables, then we use the concept of this referential integrity constraint with the concept of the foreign key and the primary key. This is an example. So this is the table. This is the table 1 and this is the table 2. This is our base table or the primary table. This is our base table or the primary table in which we have two attributes, that is the department number and the location, and we use this as a primary key. And we use this department number primary key into the table 1 as a foreign key, because this table is referencing this table. This is the referencing table or the related table that based on the primary key. So this department number act as a foreign key in this table. So it will contain only the values that will stored into the primary key, that is 1, 2, 3. So here we have used 1, 2, 3. It may be contain also the null values. Maybe there 3 is not exist here. So maybe it contain the null value. Foreign key have the null value. But it will not, we are not able to insert 5 here because 5 is not present into the department number of the base table. So we cannot insert any value that will not contain into the primary table or the base table. So here not allowed as department number as 5 is not defined because it is not defined into the primary key of the table 2 and the table and in the table 1. So department number is a foreign key defined here. So this is the concept of the differential integrity constraint, that how we check for the differential integrity. If we have insert 5 here into this referencing table or the related table, if we are able to insert this 5 here, it will not insert here. It will generate an error that we are not able to insert 5 here because this 5 is not present into the primary key. So differential integrity constraint is a base on the concept of the foreign keys. A foreign key is an important attribute of a relation which should be referred to it to other relation. We always use the concept of the foreign key whenever referring the two tables and we need to find the relation between two tables. So differential integrity constraint state happens where relation refers to a key attribute of a different or same relation. However, that key element must exist into the table. This is another example that given to us. These two tables are given to us. One table is of the customer and second table is of the billing. Again, we have the two relations, that of the customer and the billing. So here we have customer. Here we have customer ID as a primary key. Here we have a customer ID as a primary key. In this table, we have this as a primary key, and in this table, we have used this as a foreign key. So this is our base table. And in this table, this is called the related table or the reference table. So the customer ID of 1 is referenced twice into the relation billings here. So in this, we have the duplicate values into the foreign key also. We have duplicate values into the foreign key also. We have also have the null values in the foreign key, but we have not used any value that will not exist in the primary key of the base table. Then last is the key constraint that we have applied on any relation. Then any entity set can have multiple keys or candidate keys, but out of which one key will be the primary key that uniquely identify our database. We can say that in a table, it is possible that we have a number of keys, but one key we use only as a primary key that uniquely identify our database. It's not necessary that in primary key we have only one attribute. Maybe it is a composite key that will contain the number of attributes. So key constraint, if we apply any key constraint on any relation, then we have to keep in mind that all the values of the primary key must be unique, and the values of the primary key must not be null. We have to be, whenever we have apply any key constraint, then we have to be check that key in a relation, the primary key, we have only one key as a primary key. Here the student ID is a primary key, and we always keep in mind that the primary key can always be unique. This is not allowed because 102 is already here, and we again want to insert the value as a 102. So this is not allowed because all rows may be unique. And this is also not allowed if we not insert here 103. So the null values are also not allowed into the primary key. So whenever we have applying any key constraint, we have to be checked that all the values of the primary key must be unique, and the value of the primary key can never be null. So we have discussed about the 4 constraints that related to the integrity constraint, that domain, foreign key, domain differential integrity constraint, key constraint, entity integrity constraint. So we have discussed these 4 constraints when we have creating any database, when we have inserting any new data into the database, and when we have any updation, make any updation into the database. So always we check for these constraints when we have making any databases. So thank you for the day.